Hello, everyone. Welcome to the deep dive on Amazon S3. My name is Susan Chan. I'm a senior product manager with the Amazon S3 team. So Amazon have a full range of storage portfolio. If you need file, we have Amazon EFS. If you need block storage, you can choose between Amazon EBS for persistent store or Amazon EC2 for your instant store. Today, we're going to focus on Amazon S3 on the object storage. So here's what we're going to talk about. We're going to dive deep into how you can pick the right storage class for your use case. I'll talk a little bit about some of the tools we offer you to automate your management tasks so you can focus on growing your business and building your application and leave the heavy lifting to S3. I'll talk a little bit about some of the best practice you can get better performance out of S3. And I'll also go through some of the new tools that we're offering to help you manage your storage. So to start with, I'd love to hear how many of you are actually currently using S3. Majority of you. Fantastic. This is a deep dive session. I am assuming that you have some working knowledge of S3. I'm likely going to go all the way up to the top of the hour, but I will stay back to answer questions for as long as you need. And I'll have a few colleagues with me as well. So we probably won't have a time for Q&A, but I'll stay back at the end, and you can answer your questions. To start off with, let's talk about, what happened here? Hang on. Getting your data into S3. Not all data transfer is the same, we know that. And therefore, we offer a range of tools to help you get your data into S3. If you want to stream data into Amazon, you can consider Amazon Kinesis Firehose. If you have data on premises and you wanted to connect your on-premise infrastructure with the AWS cloud, consider the AWS Storage Gateway. A couple days ago, we announced that we added a file gateway, so you can use if you have on-premise application that has the NFS protocol, you can connect to your S3 bucket as an NFS mount point. So that's something new. If you have petabytes of storage in a location that doesn't have very good connectivity, you can consider AWS Snowball Edge, which has also compute power, so you can do some processing as you load your data onto the Snowball. And of course, if you have hundreds of petabyte or exabyte of data, consider AWS Snowmobile. They won't let me drive the Snowmobile on stage, but here you have it for effect. If you have data on premises, you probably have software from one of these industry leaders. Some of these can help you migrate workload onto AWS so your application can run on AWS or in a hybrid architecture mode. They make it easy for you to migrate or scale your growth, leveraging Amazon S3 and Amazon Glacier as your cloud storage targets. So once you figure out how to get your data onto the cloud, you have a choice of storage classes on Amazon S3. All three of these storage classes are highly durable, and they're designed for 11 nines of durability. Let's start with S3 standard. It is designed for active data, that hot workload that you have. It is highly performance, designed for 4 nines of availability, so it's always available. This is the general purpose storage class. When you have new data that comes in and they're frequently accessed, consider starting with S3 standard. And as data age, a lot of the times you see the access pattern to drop off. Standard infrequent access is designed for this colder and less frequently accessed data. This still have the same high performance as S3 standard. So when you need that data, you still have access to it right away. This has a much lower cost point with cost starting at 1.25 cents per gigabyte, which is 45% lower in storage costs than S3 standard. there is a retrieval cost for standard infrequent access, but if you are putting that coder object in this storage class, you are able to take advantage of that lower storage cost. And as your data age even further, at some point, no one is really actively interacting with your data anymore. You might need to keep it for record-keeping purposes. Glacier is designed for this long-term archive purpose. It has very, very low cost with storage starting at 0.4 of a cent. And earlier, we announced that there's additional retrieval option. So there are now 3 retrieval options ranging from minutes to hours. So you can choose depending on how quickly you need the data. Before I move on to this slide, I also want to mention that we have just dropped pricing for S3 standard effective today. So standard has pricing now starting at 2.3 cents per gigabyte per month. So how does all these storage classes relate to your use case? How do you pick the right storage classes? Well, here's kind of a rule of thumb. If your storage is for big data analysis, content distribution, or static website, you're likely going to see a lot of retrieval on your data. So consider starting with S3 standard, using S3 standard for those data. If your use case is for backup and archive or disaster recovery, you generally don't access this data until the very rare occasion when you need it, when your primary copy becomes unavailable. But when you need it right away. Standard infrequent access is designed for this. So I'll consider directly putting into standard infrequent access for these data. Glacier is for your long-term archive. So other than the really, really old data that you need to keep, we also see customers just directly putting into Glacier for preservation, for digital preservation. For example, earlier, Sony shared that they have just moved over 1 million hours of videos from magnetic tape into Glacier for digital preservation. So maybe you can consider, maybe you also have some of these use cases, and you can think about which storage classes you should be using. So as I mentioned, as your data age, a lot of the times, even when you start with S3 standard and your new data that you're doing your big data analysis, at some point the access pattern drops just because you've got newer data and the older data is no longer used. So the next big question is, when should you move this data into standard infrequent access? So for that, we just announced S3 Analytics, storage class analysis. What it is, it helps you visualize the access pattern on your data over time, so that you can see what the access pattern of your data is and visualize it, so you can take a data-driven approach to manage your storage. What storage class analysis help you with, other than visualizing, is it also measures the object age when the data becomes infrequently accessed. You can configure storage class analysis by the bucket, or you can also selectively configure it into prefix or specific object tags. So you can dive deep and figure out which part of your data is infrequently accessed and take advantage of that. And what storage class analysis that you do is that it gives you an easy output so that you can easily create a lifecycle policy based on the data. Lifecycle policies are based on age, so you can observe the age of the object and figure out when at what point you should set your lifecycle policy and transition that into standard infrequent access. Sorry, this is a little glitchy. So here's how storage class analysis look like. Once you enable it, you get a dashboard that looks like this. On the top of the dashboard, it tells you how long you have this enabled. Obviously, the longer you've had this enabled, the more confident you are with how long your time series is. So what you can see in here, based on the storage over the last 115 days that we've been observing this data, we're seeing that objects older than 90 days are infrequently accessed. So you can tell that in my bucket, I have 3 petabytes of storage, and I'm retrieving about 2 petabytes of it. So overall, it seems like this is actually pretty frequently accessed. I'm looking at 65% of my data. It's pretty active. So it looks like standard might be the right storage class for me. And down below, you can see the kind of the time series. So the blue is the amount of storage stored, and the purple is the amount of data retrieved. Okay. But so what we also give you, other than that broad analysis, is we also dissect your data into age buckets. So here you can see the top three box is data less than 60 days old. We are frequently accessing those. So those are, S3 standard is the right storage class for them. You can see the bottom left-hand 2 boxes, data older than 90 days. They are actually very infrequently accessed. Most all your access is actually concentrated on data that is newer than 90 days. So that is an opportunity for you to set a lifecycle policy at 90 days to transition anything that is older than 90 days into standard infrequent access. And you can see there's like out of that 3 petabyte that I saw, over 1 petabyte of that could have been in standard infrequent access. So this data this valuable data, you can also export S3 analytics. So you can use it with the tools that you wanted to use with. So you can use it with Amazon QuickSight or Excel or any of these tools that you would like. The export is an output of a flat file, so you can do the analysis in the way that you like. So how do you get started? So this is actually the management console that most of you are probably familiar with. This is our old management console. In order for you to see these new features, you need to opt in and get into the new management console. So once you opt into the new management console, you can see this new interface. You can go to the Management tab. Under Analytics, you'll be able to enable storage class analytics on the right-hand side. You can also add filters, as you can filter by prefix or by object tag, so you can have detailed analysis for a specific part of your bucket. And you can also opt to export the data, so you can use it with the tools that you want. When you enable this for the first time, it may take 1 to 2 days before you start seeing your analysis as we populate your data. So next, let's talk about how you can automate some of these management tasks. So we've talked about storage class analysis. You figured out that maybe some of your data, for my example, anything over 90 days, I should really move into S3 standard infrequent access. You can use lifecycle policy to automate all of that. Lifecycle policy allows you to set transition data into standard infrequent access or Glacier. And also, at the end, you can also set a policy to remove data that you no longer need. You can choose one or more of these actions, or you can also combine all of these actions. So you can transition to standard infrequent access in 90 days, and then later on transition to Glacier, and then at the end, expire. Or you can just choose expire if that's what you need. You can set policy at a very granular level. You can do it at the bucket level, prefix, or object tags, the same way that you can get your S3 analytics with. You can also set up different policy for current or non-current version if you have a version-enabled buckets. So this, quickly, the best way to walk through how to set lifecycle policy is actually through the management console. So this is the new console interface. The first step is you would add any filter that you wanted. By default, lifecycle policies are at the bucket level. So you can either set it at the bucket level, or in my case, in this demonstration, objects that are in prefix 1 and tagged as department equal finance will apply this, will have this lifecycle policy applied. Next, you can optionally set transition. So here, based on the observation from the storage class analysis, I'm setting my transition to standard infrequent access for 90 days after the object is created. And remember, when as object transition from standard to standard IA, there is no change in the URI, so your application don't need to change at all. The read path is the same. And here I also set to transition. So after the object is transitioned into standard infrequent access, I also ask lifecycle policy to transition into Amazon Glacier a year after the object is created. And you can also set expiration. So here I'm setting expiration for 10 years. After 10 years, I no longer need to retain my record. And so I ask lifecycle policy to remove that after 10 years. So once you set this lifecycle policy, you can move on to developing your application and managing your business. And S3 will evaluate your policy every day and make changes according to the rule that you have set. So you don't have to think about it anymore. It's all automated. So the second topic that I want to cover is policies so you can protect your data from accidental delete. We encourage you to consider versioning. Versioning gives you the ability to recover from unintended deletes or application logic failure. S3 is a highly durable storage, but we cannot tell a delete that is unintentional versus intentional. If it is a delete request, we take that delete request and we remove your object. When you have versioning enabled, what it does is that every upload is created as a new version of the object. So if you put an object in an existing key, instead of overriding that key, we'll put a new version on top of that. And so all the previous versions are preserved. When you delete an object in a version-enabled bucket, instead of removing that object, we actually put a delete marker on top. And when you read the object, it will behave as if the object no longer exists. But if you decide that that was an unintentional delete, you can remove that delete marker, and you can elegantly roll back to your previous version. So we recommend this as a best practice. So as an advanced tip, you can actually create a lifecycle bin for your storage by combining versioning and lifecycle policy. So you enable versioning on your bucket, and that creates the recycle bin as it maintains every version of your object as you write on it. And you use lifecycle policy. You can set up a non-current expiration policy to define the duration of your recovery window. For example, you want to maintain all the old version for 14 days, and beyond that, you probably don't need it anymore. So use a lifecycle expiration policy, and we just automatically remove that after 14 days of it being non-current. So the third topic I want to go through is for you to consider automating with trigger-based workflow. For example, when you get raw data into your bucket, you may want to process it. And you can automate that with event notification. You can set up event notification in response to specific changes to your object, be it object creation or deletion. And you can also be very specific that says to set up a filter on either by prefix or by suffix. So you can say, hey, only trigger the event if an object is created in my /image prefix. Or only trigger an event if an object is created that has a .raw suffix. Notification can be published into three different targets. You can publish a push notification with Amazon SNS. So you can broadcast event to a large number of clients, or you can trigger a mobile alert. You can also do a push notification with SQS queue, so your worker fleet can asynchronously process your data in the backend. A third way you can get notification is through a Lambda function. So you can trigger a notification so that the Lambda would automatically execute your code when that S3 event that you defined occurs. Lambda would run that code without you having to provision server or manage instances. So it's very convenient. We're seeing a lot of customers adopting event notification. We have customers like Human Longevity, who's using S3 event to trigger their genomics processing. We also hear that Turner, the broadcasting company, uses S3 event to trigger a Lambda function for their content processing. So think about whether or not there's a place in your application for event notification. The fourth topic I want to talk about is cross-region replication. There are many reasons why you may need to replicate across regions. You may have compliance requirements that necessitate you to store data hundreds of miles apart. You may want to enhance security by replicating data between buckets with completely separate owners and account owners. We hear Ring, who have just shared with us that the video doorbell company, they use cross-region replication, so they have data in 2 different regions to take advantage of spot instance pricing, so they can process their video at lower costs. And they also use cross-region replication to provide low latency access to their end users. So how cross-region replication works is you put a policy in that tells S3 the destination region and the destination bucket of your choice to replicate to. And once you put the policy in, we automatically and asynchronously replicate your storage. So every new upload into S3 is replicated into that destination bucket. You can also choose to replicate a full bucket or specific prefixes within that bucket. You can also choose to replicate into a different storage class. For example, if you have a mix of standard or standard infrequent access in your source bucket, and you wanted everything in standard infrequent access, you can set that as part of your replication policy. Once you set that policy, just like all the other policy, you can let S3 do the work, and you can focus on developing your application. So in summary, we've talked about 4 ways of automating management tasks. Cross-region replication as a policy. You can automate transition and exploration with lifecycle policy. Consider doing trigger-based workflow with S3 event notification. And also we recommend using versioning so that you can easily recover from accidental delete. The third big topic that I want to discuss is some of the best practices you can use to optimize S3 performance. We're going to start with faster upload. If you have a user-generated content use case, you may have customers that are uploading from all over the world into your centralized bucket. You may also, or maybe you have to transfer a large amount of data across the continent frequently in your use case. Consider using S3 transfer acceleration. S3 transfer acceleration leverages the AWS Edge network. When you enable transfer acceleration, we would automatically route your data into the closest endpoint, into the closest Edge network, so that your data travels the shortest distance, a shorter distance on the public internet, and they travel the remaining longer distance in the AWS backbone, which is an optimized network. So you get much faster performance that way. Transfer acceleration uses the standard TCP and HTTP protocol. So you don't need to change any firewall. There's no client software to upload. All you need to do is to enable transfer acceleration for your bucket, and we'll give you an endpoint, and you change that endpoint on your application. And once you do that, every upload is automatically accelerated. You will notice that the benefit of it depends on how long the distance is from your source to your destination. Generally, you'll find that the longer the distance and the larger the file, the more you benefit from using S3 transfer acceleration. So we have 68 global edge locations. We just added 3 more last week. So there's bound to be one that is close to your source region. You can also try it before you want to implement it. You can try it at s3speedtest.com from your source region. And you can see how much in your specific use case you'll benefit before you implement it. A second way of getting faster upload of large object is to parallelize put with multi-part uploads. Multi-part uploads allow you to upload large objects in a set of parts. You can upload parts in parallel or in any order. You can pause, you can resume. When you complete a multi-part upload, S3 puts the parts together and create the object for you. When you're uploading large objects over a stable network, over a stable connection with significant bandwidth, you can parallelize uploading your parts to maximize that network throughput to get multi-threaded performance. If you're uploading, on the contrary, if you're uploading objects over a spotty network, you may see your upload drops being interrupted. Using multi-part upload would actually increase the resiliency for your application to network error, because you only need to retry the 1 or 2 parts that are dropped, and you don't have to restart that upload from the beginning. Well, we talked about upload. Let's talk about download. You can also parallelize gets the same way you parallelize puts. If you're getting large objects, consider using range-based gets. Here's an example of a range-based get where I specified that I wanted to see the first 10 bytes of the object to come back. So you can parallelize with range-based gets and get your object back faster. If you know that your object was uploaded with multi-parts, you can align your get ranges with those parts so that you will actually get the best performance that way. Okay. If you're doing lots of gets on the same object over the internet, consider using Amazon CloudFront. CloudFront is integrated with S3, and what it does is it caches the object at the edge locations. What it does, once it caches the object in the edge location, then your end user will see much lower latency data transfer to them. And so the performance of their get object is much better that way. Well, the third topic that I want to get to is what are the ways that you can get higher requests per second out of S3 by distributing your key names. You only need to consider this if you're planning to have an application that would spike over 100 requests per second on your bucket. S3 routinely scales up to millions of requests per second. And the way we do that is that we spread your key names among partitions. And we do that automatically over time as we see your request rate increase. It's interesting to know that our index layer is sorted in an alphanumeric order, the same way you see the result when you list your bucket. So if you name your objects starting with a date, which is quite common, all of these keys will actually fall into the same partition. And if when you spike to hundreds of thousands of requests per second, it is likely that you might get throttle. And so we want you to consider adding randomness to the beginning of your key name, either with a hash or a reverse timestamp, So it would look something like this. And as you can see, every one of these key names now would fall into a different partition. And so your transaction can be distributed across partitions, and you'll be able to get much higher requests per second without getting throttled. The last topic I want to talk about for performance is list. As you know, the S3 list request paginates at 1,000. So we give you 1,000 records at a time. If you have a bucket with lots and lots of objects, you may spend significant amount of time and effort just to try to list your bucket. So let us do that for you. We're introducing S3 inventory. What it is it is a scheduled alternative to the synchronous list. You can get the list result delivered to you in your bucket, either on a daily or a weekly basis as a flat CSV file. So you can instruct us to list either the full bucket or by specific prefix. And what's better is pricing of that is half of our synchronous list API at $0.25 cents per million object listed. And I want to give you a quick getting started with our new management console. It is also under the management tab. Go to inventory under management, and you can you specify the destination bucket of your choice. You can specify either a daily interval or weekly interval. If you have a version-enabled bucket, you can choose to only list the current version of those objects, or you can also ask us to list everything. You can also choose optional fields, additional fields to include in the inventory report, including replication status if you're doing cross-region replication. Let's see. We also want to make sure that you're aware that you need to give us permission to write to your bucket. You know, when you add your inventory report, when you enable inventory report, we want to make sure that you're giving us the right bucket policy to allow S3 to write to your bucket. So in summary, we've kind of gone through a lot of best practices. We'll give you 2 ways to get faster upload through S3 transfer acceleration or S3 multi-part upload. We talked a little bit about key naming for high TPS workload, and a couple ways to optimize your get performance, as well as optimize lists by using S3 inventory. Now let's move to some tools that would help you manage your storage. As you store on S3, you are probably used to organizing your data by location. As we're a flat namespace storage, you probably are organizing it by bucket or by prefix. We're introducing S3 object tags, so now you can organize your data based on the nature of data, based on what it is. S3 tags, object tags, are key value pairs that you can apply to an object. You can put as many as 10 tags per object. With tags, you can set up an IAM access control policy, so you can control access. You can set up a lifecycle policy with tags, as I previously mentioned. You can also customize storage metrics and analytics with tags. There are 2 ways that you can tag your object. One is when you put your object in your put object request, you can enable the you can put your tags as part of the tag header. Or you can also add tag to existing object with a separate API. Tags can be created, edited, or deleted at any time during the lifetime of the object. Here's an example of how you can manage access with object tags. This user permission policy grants the user get object permission to the object in example bucket that has been tagged with project X. So as you can see, you can now use tags to basically manage access with the policies. Well, to manage your storage, you also need the ability to audit and monitor access. You can do that by enabling CloudTrail, AWS CloudTrail. CloudTrail logs captures bucket level and both bucket level and object level details. You might have been familiar with the bucket level details, which we've had for about a year. And last week, we just added object level detail, which we're calling data events. For each request, the log would include who made the API, all the details, who made the API calls, when it was made, what resource was affected. So you can use the logs to perform security analysis, meet your IT auditing needs, as well as understand what your end user behavior is, and also consider changing some of your policy to tighten access control if it needs to be. The logs are delivered directly to your S3 bucket of your choice. You can enable CloudTrail logs at the bucket level. Pricing is 10 cents per 10,000 data events. And there's also charges for storage. You can also optionally set a notification so you get notified when the log is delivered to your bucket. Who of you are running a web, mobile, or business application that depends on your cloud storage? Oh, lots of you. So you'll probably be interested in on the visibility in your storage performance, so you can see how the storage is operating against your application. Amazon CloudWatch metrics will be something that you should consider. CloudWatch metrics give you the visibility into storage performance, so you can quickly identify and act on any operational issue that comes up. You can use with CloudWatch metrics, we've just added 13 new metrics, including request level metrics, as well as bandwidth metrics in 1-minute granularity. So these are really good for, the use cases for operational metrics. You can also set CloudWatch alarm to get an alert if the metrics exceeds the level that you have predefined, so you can act on issues timely. For example, you can see 400 series error, and you can set a level where you would like to get page, because those are the time when your end user is getting their performance impacted. You can configure metrics by the bucket, prefix, or tags, so you can align your metrics and customize the alert to the specific application or workflow that you're monitoring for. Metrics is 30 cents per metric per month. I want to show you a little bit about how it looks like. So this is how it looks like. It is also part of the management tab within the AWS S3 console. And what you can see, this example is the total request latency in millisecond per request. And you can see that you can hover over each of these data points, and it would actually shows you the reading on it. So you can get real-time operations and performance of your storage. When you enable this for the first time, it may take up to 15 minutes to see the metrics start flowing. And you can also see on the top there, you can get a time series of it. You can choose anywhere between 1 hour all the way up to 2 weeks, so you can see how your operations is doing historically as well. So we added 13 new metrics to CloudWatch. We have existing, before this, we have storage metrics, so you can see object count and how much storage you have. So they're storage-related metrics. And now we have just added 13 more, including 9 request-related metrics, so all the different kinds of requests, as well as 400 or 500 errors and latency-related metrics. And you can set alarms on any of those in the CloudWatch console. Okay. Here's how you get started. You'll probably be familiar with this console now. Under the Management tab, in the middle is the metrics. In the middle is the Metrics tab. You can enable metrics on the left side of the console by checking the box. You can add filter. Under the filter column, And again, once you enable this, you'll start seeing metrics flowing in about 15 minutes. Okay. So in summary, we've talked about quite a few ways for you to manage your storage. You can classify your storage and manage access using S3 object tags. You can audit and monitor access using AWS CloudTrail logs. You can also monitor your operational performance and set an alarm with S3 CloudWatch metrics. And to recap, we've kind of gone through quite a bit today. To recap, we've talked about how you can pick the right storage class for your use case, including some tools to help you do that. We've talked about how to automate management tasks, some of the best practices you can use to optimize your S3 performance, as well as tools to help you manage storage. So, and I think with that, actually, one thing that before I end this presentation, if you're interested in how one of our customers uses S3 for their big data platform, FINRA is sharing their architecture and their experience in the next hour in Venetian Ballroom B. So you can go and listen to them, listen to their experience firsthand if you like. So with that, I will actually conclude this this presentation, and I'm going to stay out in the foyer here to take any questions you have. Thank you very much.